You read the title. Yes, this village runs on fat. Animal fat. In homes without gas, oil, or electricity, a slaughtered animal yielded more than meat. The offcuts were rendered into tallow, and meadow rushes were shaped to carry it. This is how scrap became stored daylight. In a subsistence economy, this secondary harvest turned refuse into an evening's work. Raw fat will not keep. It spoils, smokes, and fouls a room when set alight. The village answer was rendering. Controlled heat applied long enough to drive out tissues and water, leaving a clean, hard tallow. Once reduced to a stable form, the fuel could be handled, traded, and remelted as needed. Suet from the kidney fat and trims from butchering were brought to the bench. Knives worked close, taking gristle away and cutting the pieces to even size. Small cubes render at the same pace. Large lumps scorch outside before the center loosens, so regularity matters. Pots were set over low fire. Gentle heat is the rule. With dry rendering, the pot holds only fat. The first melt frees liquid that bathes the rest. With wet rendering, a measure of water sits beneath the fat, forming a heat buffer. It slows scorching, lifts soluble impurities, and curbs the harsh smoke that would later reappear in the lamp. As the temperature rises, membranes tighten, then collapse. Connective tissue contracts into fine cracklings. They float and brown. The sound drops to a quiet simmer. In a well-tended pot, bubbles are small and steady. A furious boil breaks solids apart and darkens the liquor, locking in smoke and odor. The keeper stirs with a flat paddle, scraping the base to prevent sticking. Edges are checked. Corners of the pot run hotter and can char. When most pieces have given up their load, the surface shows a clear, wet shine. This sheen is the goal. Clarified fat holding light, not waste. Liquid fat is drawn off through cloth. A coarse linen or tow catches skin, hair, and brittle scraps. The first strain runs into shallow pans. Wide surface and still air help particles settle. After a short rest, a skin may be skimmed from the top and dark fines lifted from the bottom. Each pass removes what would smolder later. If more purity is needed, the tallow can be remelted with clean water and a pinch of salt, then cooled again. Water traps soluble taints and draws them down. The cooled cake lifts free, the underside wiped where gray residue clings. The extra step costs fuel but returns a quieter flame. Cooling sets the fat. In a cool room, the pans turn from liquid to firm blocks. Good tallow cuts cleanly. It is pale and waxy, without wet patches. A greasy smear or damp holes tell of water trapped inside, which will spit in the dip pot and disturb a wick. Blocks are wrapped in cloth to keep dust out and are stacked in a dry place. Mice are kept off. Heat is the enemy. Summer storage asks for shade and air. When light is needed, a portion is shaved, placed in a long trough or griddle, and warmed slowly to a steady liquid. This is fuel with discipline. It travels, melts predictably, and smokes less under a careful flame. One may think of it like well-seasoned timber, unstable when green, but strong and reliable once the excess has been driven off. Tallow gives time back to the evening without demanding great expense. The barnyard odor does not vanish. It softens. A low scent hangs near the pot, and a faint trace returns when the lamp is fed. Rafters will take a film of soot over months. Households accepted this cost because the gain was certain. Light when daylight failed. By turning a perishable scrap into a uniform cake, the village secured a controllable supply of illumination. After the last pan has set and been stowed, the work shifts from fuel to flame. Once the tallow stands ready, the problem becomes simple and exacting. Make a wick that wastes none of it. How can a marsh plant carry a flame that rivals a small candle? With a knife, a steady hand, and a strip of pith cut to serve as both carrier and control. The common rush grows where ground holds water. In meadows and ditches, juncus stands by the thousands. For a village, this is free material gathered with simple tools and careful coordination. Once the fuel is sound, this plant becomes the wick that spends it wisely. The plant cannot burn as found. Whole stems blacken, buckle, and die out because the husk traps steam and the soft core collapses under heat. Preparation turns a green stalk into a capillary spine that will lift melted tallow to the flame at a controlled rate. Harvest waits for late summer. Mature rushes are cut clean at the base with a small knife or sickle. Workers bind them in loose sheaves so air can pass between stems. If left wet or crushed, mildew softens the core and ruins the draw. Bundles are moved under cover. Rafters or beams take the load. Stems hang in freely moving air to dry without bleaching in direct sun. The aim is firm pith, not brittle sticks. A week or two in good weather will set the stems for work. Peeling begins with a score down the length. The blade works shallow to avoid cutting the white pith. Hands roll the stem as the dark green rind is lifted away. Most of the skin is removed, but not all. A narrow strip, no wider than a thread, remains along one side. That saved strip does two jobs. It braces the pith against sagging once heat softens the fat, and it forms a capillary path that resists full collapse under the flame's pull. Without it, the core slumps and the feed of liquid tallow falters. With it, the rush holds line and draws steady. Lengths are sorted. Weak pieces are rejected. Good spines share even thickness and unbroken pith. At the bench, the worker keeps a rhythm. Score, peel, inspect, and set aside. A pile grows, light as straw and ready for coating. The dipping station is simple and exact. A long griddle or trough holds melted tallow at steady heat. The surface should quiver, not boil. A reed dipped into a roaring pot will load too much fat and smoke. A tepid bath will set in ridges. Stable temperature is the rule. Each rush goes through in passes. Dip, lift, and hang. Cool a moment, dip again. Thin coats build a jacket that does not crack. They also limit runs, so the finished stick will not drip molten fat into the holder. Too much too fast produces a bulbous coat that smolders and gutters. The hand learns the pace. If a coat dulls to matte, it can take another pass. If it still shines wet, it must wait. Ends are sometimes weighted with a little extra tallow to help the first light catch and to protect the clamp point from charring. The rest is kept even, no thick knots. As coats build, some makers roll the still warm rush between flat boards. This compresses ridges and seats the fat into the pith. Others draw it between two fingers to remove sags. The goal is a straight, uniform carrier that feeds the flame as a well-laid wick in a candle would, but at a fraction of the cost. Finished rushlights stack lightly on trestles. They cure to a quiet sheen. When lit, each length gives a short, bright service, often 10 to 20 minutes, enough to sort grain, stitch a seam, or read a brief note. They are not social light, they are task light. If documenting traditional working methods like this matters to you, consider subscribing. These episodes preserve techniques that once shaped everyday life. Because this method trades labor for thrift. Wild plants and rendered scraps become controlled minutes of illumination. The value lies in predictability. A set burn, a known output, and a piece that can be made in number by ordinary hands. With the light fabricated, attention moves from making to keeping. A rushlight stands or fails by how it is held, tended, and advanced through its brief life at the flame. Why did poor homes favor rush over candle? The answer sits in the iron jaws of a rushlight holder and in the clockwork of chores that filled every evening. Once the tallow stands ready, light is governed by hardware and habit. The cheapest flame still needs control. A rushlight holder is direct, workmanlike kit. Iron jaws, sometimes mounted to a wooden stem, bite on the coated pith. The clamp stands at a fixed or adjustable angle, set off a stout base or pegged to a wall. The form is spare for a reason. It must hold, feed, and not catch. Angle is the first discipline. A slight downward tilt drives melted tallow toward the burning tip without drowning it. Too flat, and the feed starves. Too steep, and hot fat floods the ember, smothering the fire and wasting fuel. Makers learned the sweet line by trial and kept to it. Jaws matter as much as angle. Narrow, serrated lips grip the skin strip without crushing the soft core. If the clamp bites too hard, capillaries collapse and the flame pulses. If too loose, the rush slips, dropping ash and spraying sparks. Good clamps secure, then release with a clean pinch. Rushlights sputter when overfed, smoke when the coat is thick, and gutter in drafts. Hardware alone cannot solve this. Doors are kept close. The holder stands away from open hearth turbulence. A small windbreak, a crock, a board, can steady the draw so the flame eats at a measured rate. Routine keeps the flame even. As the tip chars, it is nipped back with a knife or pinched to break the dead carbon. The rush is advanced a finger's breadth through the jaws. The clamp is readjusted to maintain the tilt. A shallow pan sits beneath to catch any drip of hot tallow. Households kept several lengths ready. One burns while another cools from a fresh dip. Children learn the pace. When the light shortens, bring the next. Tasks are cued to burns. Sort grain, mend a strap, copy a line. Each stick is a short appointment, and work moves in these measured spans. Compared to this, a tallow candle is steadier and lasts longer, but it charges more per hour. It asks for a textile wick, a mold or repeated dipping, and a heavier draw on the tallow store. It wants trimming too, or the wick mushrooms and smokes. The candle frees a hand. The cost binds the purse. For a household counting every resource, the numbers drive choice. Rushes grow wild and wait for cutting. Offcuts from the bench and suet from butchering melt to coat them. The outlay is labor and a little iron. A single shop-bought candle can equal a day's pay. A month of rushes asks for a walk to the marsh and steady hands. The atmosphere tells the truth of this light. Warm tallow lends a low, fatty odor. A fine soot tracks the beam of air to the rafters and marks it in faint gray. The flame is bright up close and falls away quickly. You stand near your work. You finish the task before the stick is done. As the burn progresses, control shows in small moves. The holder's arm is swung a degree to correct a flare. The char is flicked off before it folds. If the coat runs, the next rush will get thinner dips. This is traditional craft applied to the humblest object, a controlled feed of fuel to a living edge. So what was a rushlight, and how did it differ from a tallow candle? A rushlight is a tallow-soaked rush pith gripped in a clamp, giving brief, bright, inexpensive light for short work. A tallow candle is a solid tallow column with a textile wick, steadier and longer, but costlier per hour and dear to replace. With the craft and the economics clear, attention turns outward. After the holder is set and the chores aligned to its minutes, the village meets the night with shared finite light, and the manner of that meeting shaped life after dark. Evenings were counted in handmade minutes. Wetlands and rendered scraps became measured time. Light was not assumed. It was prepared. Under safe modern conditions, clear ventilation, non-flammable surfaces, and proper fire control, the process can still be observed today. It reveals how precision and thrift once governed every flame, and how finite light disciplined evening work. This was only one of many systems that sustained daily life. There were many more.